Ever wondered what happens when Tesla tackles the world's toughest highways and your kitchen chores simultaneously? Today, we're peeking inside Gigafactory Nevada, where fresh semi-chassis hint at a 2025 mass production sprint, and into Tesla's R&D labs, where Optimus learns to flip a steak by binge-watching YouTube. Buckle up. We're exploring how eased tariffs, factory upgrades, and cutting-edge AI are steering Tesla's next big leaps in trucking and robotics. In other exciting news, Tesla is getting closer to the milestone of mass production of the Tesla Semi by the end of 2025, with clear signs at the dedicated factory in Nevada. New frame and components of the Tesla Semi have been spotted outside the production facility at Gigafactory Nevada, indicating that the company is rushing to prepare for mass production. According to Tesla, the factory is expected to start producing the first units later this year and reach peak capacity in 2026. With the goal of producing 50,000 semis per year when operating stably. This is an important step in Tesla's ambition to replace diesel trucks with electric trucks, contributing to reducing emissions in the transportation industry. To support this plan, Tesla resumed ordering components for the Tesla Semi and Cybertruck from China, after the tariff tensions between the United States and China were eased in mid-May 2025. Previously, high tariffs of up to 145% imposed by the Trump administration had caused Tesla to temporarily suspend imports of components, affecting production plans. The reduction of tariffs to 30% from the U.S. side and 10% from China has enabled Tesla to continue its global supply chain, optimize costs, and ensure production progress. And finally, Tesla Bot is revolutionizing robotics with its ability to learn tasks at an unprecedented pace, up to 100 new tasks daily by watching videos, such as YouTube tutorials. This humanoid robot, developed by Elon Musk and Tesla, is designed to perform a wide range of activities, from household chores to industrial tasks, showcasing its potential as a versatile assistant. Optimus leverages a single neural network to execute commands, such as sweeping, cooking, vacuuming, and sorting factory components, demonstrating its adaptability in both domestic and industrial environments. A key feature of Optimus is its advanced learning capability. Unlike traditional methods like motion capture or teleoperation, Optimus learns by observing videos of humans performing tasks. For example, it can watch a chef cook a steak, practice the task billions of times in a simulated environment, and refine its approach until achieving near-perfect results. This method allows Optimus to master simple tasks like cleaning or stirring a pot in minutes, far surpassing human learning speed, which often takes weeks or months. Users can also teach Optimus directly by demonstrating tasks such as ironing a shirt, and the robot will adjust and improve based on feedback. Optimus's ability to use both hands marks a significant improvement in coordination and motor control. Previously limited to single-arm tasks, it can now handle more complex actions, like sorting parts in a factory while maintaining balance and avoiding collisions. This development, although not yet at the 22 degree of freedom hand capability, hints at future potential for even more intricate tasks. The robot's learning system is inspired by Tesla's full self-driving technology, using real-world video data to train its AI, enabling rapid skill acquisition without constant human input. A groundbreaking aspect of Optimus is its collaborative learning model. When one Optimus learns a task, such as assembling a cybercab part, it uploads the knowledge to a shared system, allowing all other Optimus robots to instantly acquire the skill. This system enables exponential learning growth. With 1,000 robots learning one task daily, the network could amass 1,000 new tasks each day. This capability was demonstrated in a video of multiple Optimus robots dancing in sync, highlighting their shared knowledge and uniformity. Optimus is powered by a 2.3 kilowatt-hour battery, providing at least 8 hours of operation, though this varies depending on the task. Walking or lifting heavy objects consumes more energy than light movements like sorting. While Optimus excels at simple tasks like wiping surfaces, concerns exist about potential misuse if exposed to harmful content, such as videos teaching dangerous skills. To mitigate this, Tesla could implement AI filters to screen videos for inappropriate content and restrict learning to verified sources, ensuring safety. To achieve the level of refinement required for true commercialization, Tesla still has significant work ahead with Optimus, including enhancing AI software, improving hardware durability, and ensuring the robot can operate reliably for extended periods across diverse environments. An additional year of training is necessary to address these challenges, ensuring that by Q3 2026, Optimus meets the high expectations set by Tesla. On pricing, the $20,000 figure mentioned by Elon Musk has sparked debate. While ambitious, this target is unlikely at launch. We estimate Optimus' starting price will range from $40,000 to $50,000 in 2026, reflecting the real challenges Tesla faces. According to Musk, the Optimus production line has yet to reach optimal cost efficiency. Humanoid robotics is a new frontier, and the supply chain for critical components like sensors, motors, and batteries had to be built from scratch. Additionally, many key parts still rely on suppliers in China, where costs and logistics can fluctuate due to global economic and geopolitical factors. Musk has stated that the $20,000 price point will only be feasible once Tesla scales to producing 1 million robots annually, a milestone he predicts around 2029 or 2030. Until then, a higher price is inevitable, but it also reflects the unique value Optimus offers, from rapid learning to its potential in both household and industrial applications. Elon Musk has called Optimus Tesla's biggest product, predicting insatiable demand due to its transformative potential. In homes, Optimus can handle chores like cleaning and cooking, while in factories it can sort components and assemble parts, enhancing efficiency. Its rapid learning, collaborative system, and versatility make Optimus a game-changer, poised to redefine robotics and automation across industries. Tesla's charging into the future on two fronts: zero-emission freight rolling off the line, and humanoid robots absorbing skills at breakneck speed. Which breakthrough gets you more pumped? The semi-revolution on America's roads, or Optimus turning your home into a sci-fi scene? Hit like if you're on Team Semi, tap subscribe for your daily Tesla lowdown, and drop a comment with your pick. See you tomorrow for another deep dive. Stay electrified.